Creating an Azure Machine Learning, Azure ML workspace is a foundational step in designing and preparing a machine learning solution. The workspace acts as a centralized place to manage all the resources needed for your machine learning projects. It provides a collaborative environment for data scientists and developers to build, train, and deploy machine learning models. In this presentation, we will delve into the various aspects of creating and configuring an Azure ML workspace, ensuring you have a comprehensive understanding of its components and functionalities. An Azure ML workspace is a cloud-based environment that contains the resources needed for machine learning. It includes storage for datasets, compute resources for training models, and tools for managing experiments and deployments. The workspace also integrates with other Azure services, providing a seamless experience for end-to-end machine learning workflows. By centralizing these resources, the workspace simplifies collaboration and enhances productivity, making it easier to manage and scale machine learning projects. Using an Azure ML workspace offers several benefits. It provides a unified platform for managing all aspects of the machine learning lifecycle, from data preparation to model deployment. The workspace supports collaboration, allowing multiple users to work on the same project simultaneously. It also offers scalability, enabling you to easily adjust compute resources based on your needs. Additionally, the workspace integrates with various Azure services, such as Azure Data Lake and Azure Databricks, enhancing its capabilities and flexibility. To set up an Azure ML workspace, you need an Azure subscription. Once you have a subscription, you can create a workspace through the Azure portal, Azure CLI, or Azure SDK. The process involves specifying a resource group, workspace name, and region. After creating the workspace, you can configure additional settings, such as linking to existing storage accounts and compute resources. This setup process ensures that your workspace is tailored to your specific needs and ready for machine learning tasks. The Azure portal is a web-based interface that allows you to manage your Azure resources, including your Azure ML workspace. Through the portal, you can access various features and tools, such as the Machine Learning Studio, which provides a visual interface for building and managing machine learning models. The portal also offers dashboards and monitoring tools to track the performance and usage of your resources. Familiarizing yourself with the Azure portal is essential for effectively managing your Azure ML workspace. Storage is a critical component of your Azure ML workspace, as it holds the datasets and models used in your machine learning projects. Azure ML supports various storage options, including Azure Blob Storage and Azure Data Lake Storage. When configuring storage, you need to consider factors such as data size, access patterns, and security requirements. Properly setting up and managing storage ensures that your data is readily accessible and secure, facilitating efficient machine learning workflows. Compute resources are essential for training and deploying machine learning models. Azure ML offers various compute options, such as Azure Machine Learning Compute, Azure Kubernetes Service, AKS, and Azure Databricks. Each option has its own advantages and use cases. For instance, Azure ML Compute is ideal for training models, while AKS is suitable for deploying models at scale. Configuring the right compute resources ensures that your machine learning tasks are performed efficiently and cost-effectively. Datasets are the foundation of any machine learning project. In Azure ML, you can create, manage, and version datasets to ensure consistency and reproducibility. The workspace provides tools for importing data from various sources, such as local files, Azure Blob Storage, and Azure SQL Database. You can also pre-process and transform data using Azure ML's data preparation tools. Proper dataset management is crucial for building accurate and reliable machine learning models. Experimentation is a key aspect of machine learning, involving the testing of different algorithms and hyperparameters to find the best model. Azure ML provides a robust experimentation platform, allowing you to track and compare multiple runs. You can use tools like Jupyter Notebooks and the Azure ML SDK to conduct experiments and train models. The workspace also supports automated machine learning, which simplifies the process of model selection and hyperparameter tuning. Effective experimentation leads to better performing models. Once you have trained a machine learning model, the next step is deployment. Azure ML offers various deployment options, including real-time endpoints and batch scoring. You can deploy models to Azure Kubernetes Service, AKS, Azure Container Instances, ACI, or even edge devices using Azure IoT Edge. The workspace provides tools for managing deployments, monitoring performance, and scaling as needed. Successful deployment ensures that your models are accessible and can deliver value in real-world applications. After deploying a model, it is essential to monitor its performance and manage its lifecycle. Azure ML provides tools for tracking model metrics, detecting data drift, and retraining models as needed. You can set up alerts and dashboards to stay informed about the health and performance of your models. Effective monitoring and management help maintain the accuracy and reliability of your machine learning solutions, ensuring they continue to deliver value over time. Collaboration is a key feature of the Azure ML workspace, enabling teams to work together on machine learning projects. The workspace supports role-based access control, RBAC, allowing you to assign different permissions to team members based on their roles. You can also share datasets, experiments, and models with collaborators, facilitating seamless teamwork. By fostering collaboration, the workspace helps accelerate the development and deployment of machine learning solutions. Azure ML integrates with a wide range of Azure services, enhancing its capabilities and flexibility. For example, you can use Azure Data Factory for data ingestion, Azure Databricks for data processing, and Azure DevOps for CI/CD pipelines. These integrations enable you to build comprehensive machine learning workflows that leverage the strengths of various Azure services. Understanding how to integrate Azure ML with other services is crucial for creating robust and scalable machine learning solutions. Security and compliance are critical considerations when working with machine learning in the cloud. Azure ML provides various security features, such as encryption, network isolation, and identity management, to protect your data and models. The workspace also complies with industry standards and regulations, such as GDPR and HIPAA, ensuring that your machine learning solutions meet legal and ethical requirements. Implementing robust security and compliance measures helps safeguard your machine learning projects. Managing costs is an important aspect of using Azure ML. The workspace provides tools for monitoring and controlling expenses, such as cost analysis and budgeting features. You can optimize costs by selecting the right compute resources, using spot instances, and scheduling jobs during off-peak hours. Additionally, the workspace offers pricing tiers to suit different needs and budgets. Effective cost management ensures that you can leverage the power of Azure ML without exceeding your financial constraints. To get the most out of your Azure ML workspace, it is essential to follow best practices. These include organizing your workspace resources logically, using version control for datasets and models, and implementing robust security measures. Regularly monitoring and optimizing performance, as well as fostering collaboration among team members, are also crucial. By adhering to best practices, you can maximize the efficiency, scalability, and reliability of your machine learning projects. To illustrate the power of Azure ML, let's look at a case study of a successful implementation. A retail company used Azure ML to build a recommendation system that personalized product suggestions for customers. By leveraging the workspace's experimentation and deployment capabilities, the company was able to develop and deploy a high-performing model quickly. The integration with Azure Data Lake and Azure Databricks enabled seamless data processing and storage. As a result, the company saw a significant increase in customer engagement and sales. The field of machine learning is constantly evolving, and Azure ML is at the forefront of these advancements. Future trends include the increased use of automated machine learning, AutoML, the integration of AI with IoT devices, and the adoption of federated learning for privacy-preserving model training. Azure ML is also expected to enhance its support for open-source frameworks and tools, providing even more flexibility for data scientists and developers. Staying informed about these trends will help you leverage the latest innovations in your machine learning projects. Creating an Azure ML workspace is a crucial step in designing and preparing a machine learning solution. By understanding its components, benefits, and best practices, you can effectively manage and scale your machine learning projects. As you move forward, Consider exploring additional Azure services and staying updated on the latest trends in machine learning. With the right tools and knowledge, you can harness the full potential of Azure ML to drive innovation and achieve your business goals.